In this video, we're going to look at the slope of a line. The slope of a line is a number that gives a measure of the line's steepness and direction. Positive sloped lines go up from left to right, and negative sloped lines go down from left to right. The steepness of the line is determined by the magnitude or the absolute value of the slope. So a line with a slope of positive 3 is more steep than a line with a slope of 1/2. A line with a slope of negative 2 is more steep than a slope of negative 2/3. So the closer the slope is to 0, the flatter the line. And when the slope is equal to 0, the line is flat. It's a horizontal line. We'll also consider vertical lines, which have an undefined slope. There is no number to represent the slope of a vertical line because it's infinitely steep. The slope of a line is the ratio of the vertical change to the horizontal change between any 2 points on that line. The vertical change is the change in the y-coordinates, or the y-values, between those two ordered pairs, and the horizontal change is the change in x, or the change in the x-coordinates between those two ordered pairs. This ratio is also known as rise over run, vertical change over horizontal change. If we know two ordered pairs on the line, then the formula for the slope is the difference between the two y-coordinates over the difference between the two x-coordinates. So if we label the two ordered pairs in this diagram with these coordinates, here I've labeled the first ordered pair x1, y1, and the second ordered pair x2, y2. In our examples, we'll have numbers for these coordinates, and we'll plug those numbers into this formula. But you can see here that the numerator, the change in y, is the difference between these two y-coordinates. And the change in x is the difference between these two x-coordinates. So let's look at an example where we compute the slope of a line passing through two ordered pairs using this formula. In this first example, we're asked to find the slope of the line passing through the 2 points, -1, 2, and 3, 8. And we'll sketch the graph of the line passing through these 2 points to see what that slope looks like. First, let's label the two ordered pairs with the notation that we'll be using for this formula. I'll label the first ordered pair as x1, y1, and the second as x2, y2. It won't matter if you switch these, the formula will come out the same either way. Here I've plotted the two ordered pairs and sketched the line that passes through them. So we'll be calculating the slope of this line. We can see it's going up from left to right, so we expect to get a positive slope for this line. Here's the change in y and the change in x that will give us our ratio for the slope. Since these are all whole numbers, we can actually just count to find these values. X is going from -1 to +3, so we have a change of 1, 2, 3, 4 units. The y-coordinates are going from +2 to +8, so we have a change of 1, 2, 3, 4, 5, 6 units. So the slope of this line will be +6 over +4, and 6 over 4 will reduce to 3 over 2. This is what the formula will give us, so that you won't have to draw the diagram and count every time you compute a slope. Plugging into the formula, the numerator is y2 minus y1, that's 8 minus 2, and the denominator is x2 minus x1, 3 minus -1. 3 minus -1 is the same as 3 plus 1 because of the double negative, and that gives us 6 over 4, which reduces to 3/2. Notice in our diagram, using the two ordered pairs, we see that when x changes by 4 units, y must change by 6 units. And that's the same thing as saying that when x changes by 2 units, y must change by 3 units. Here, if we move 2 units to the right, we'll move 3 units up to get to another point on the line. And that will work for any ratio that's equivalent to 3/2. Another example would be 9/6 if we multiply top and bottom by 3. So in that case, if we move 6 units to the right, we'll move 9 units up. Another important way to interpret the slope is not as a ratio of two separate values, but as a single number, in this case 3/2, or 1.5, and that single number will give you the change in y when x is increased by 1 unit. So if we move 1 unit to the right, we will move 3/2, or 1.5 units up to get back to the line. That's particularly helpful if your slope is given as a decimal, like 1.5, and you don't have a numerator and a denominator to use as rise over run. Also note that if we label these two ordered pairs in the opposite order, we'll get the same value for the slope. So if we switch these two labels, we have y2 minus y1, 2 minus 8, and x2 minus x1, -1 minus 3. That just changes the order of the subtraction in both the top and the bottom, so we're going to get opposite signs. -6 over -4. So we're looking at this now as going down 6 units and left 4 units. The negatives in the top and the bottom will cancel, so this is exactly equal to 6/4, or 3/2. So the important thing when you plug these ordered pairs into the slope formula is to be consistent with the order of the two values. If you start with the y-coordinate from this ordered pair in the numerator of the slope, then you need to start with the x-coordinate from the same ordered pair in the denominator. Let's look at another example. Here we're finding the slope of the line passing through the ordered pairs 1, 4 and 7, 1. Here I've plotted the two ordered pairs and sketched the line that passes through them. This line is going down from left to right, so we expect to get a negative slope. When we look at the vertical and horizontal change between these two ordered pairs, you can see that we're going 6 units to the right, so we have a horizontal change of +6, and 3 units down, so we have a vertical change of -3. That means the slope should be -3 over +6. Let's compute that slope using the slope formula with the two ordered pairs. Again, here I've labeled the first ordered pair as x1, y1, and the second ordered pair as x2, y2. Now we'll plug into the slope formula. We'll have y2 minus y1. That's 1 minus 4 over x2 minus x1, 7 minus 1. And this is equal to -3 over +6. -3 over 6 reduces to -1 over 2. And when you have a negative slope, you can either write the negative in front of the fraction or in the numerator. And any ratio equal to -1 over 2 will give us the horizontal and vertical changes between two ordered pairs on this graph. Here we're going 6 units to the right and 3 units down, but we could also go 2 units to the right and 1 unit down. Here's 2 units to the right and 1 unit down. We could also go 4 units to the right and 2 units down, because -2 over +4 will also be equal to -1/2. Remember, we can also interpret this as a single value, the change in y when we increase x by 1 unit. So if we go 1 unit to the right, we will go 1/2 unit down. And we'll get the same value if we label these ordered pairs in the opposite order. That gives us +3 over -6. Notice that this fraction is equivalent to the first one because we have the opposite signs in both the numerator and the denominator.